Right, so the purpose of this video is to look at a situation that involves a system of equations and to see how matrix inverses can actually be a very helpful tool in solving this system. So here what we have is we're splitting an investment between three different bonds. We have AAA, A, and B, and they all carry different interest rates. If you'd like to, you can pause the video to read the question. And we have some conditions that need to be met for the investors. So looking at the situation in part A, so I'm going to call X the amount of money in the AAA. I'm going to say Y is the amount of money in the A bonds, and Z is the amount of money in the B bonds. So we have a total investment of $25,000, which tells you that the sum of X, Y, and Z has to be $25,000. We're also told that we want an annual return of $1,650, which means how much interest did I earn on this investment. So what we know is that 6% of whatever I put in the AAA account or bonds and 6.5% of whatever I put in the A bonds and 8% of whatever I put in the B bonds is going to give me $1,650. And the last equation, or the last situation, or the last condition seems to be that we want twice as much in the AAAs as we do in the Bs. Now this equation is going to look a little bit backwards, but what that means is whatever X is, it needs to be twice what Z is. So X equals 2Z. But what I'm going to do, since I want to set this up as a matrix, I need the variables on one side. So, whoops, I almost took out the number up here too. That eraser's kind of massive. So X minus 2Z equals 0. So now it's ready to be set up in matrix form. So what we have in matrix form is 1, 1, 1, 0.06, 0.065, and 0.08. 1, 0, negative 2. Need that placeholder for the Y. So that's my A. And I know that my variable, or my unknown column matrix, we call that X. And we know that that's going to be equal to 25,000, 1650, and 0. So we know, and we call that B. So we know that the solution X is equal to A inverse times B. So I'm going to go to the calculator. I'm going to show you what I have here. I already have put in the matrix for this and problems B and C as well. But, whoops, you weren't supposed to see that yet. So if I go to matrix and I just press A here, there's the matrix A. As you can see, it is the same exact thing. So the beautiful thing is, what I'm going to do is I'm going to do second matrix, and I'm going to do A again, and I'm going to find its inverse just so we can see what the inverse is. And you notice that no fraction key is necessary because they're all whole numbers. So that would make the computation easier if you wanted to do this without a calculator. Naturally, finding the inverse without a calculator would be a terrible experience, but probably rewarding at the end, especially if you got the correct answer. So with the calculator, at least, I can just find, so I'm going to do matrix A inverse, and I'm going to do matrix again B. That's an implied multiplication, so I can write those next to each other. It will multiply those matrices, and I get my solution. So it looks like my solution is 10,000 in each of the first two accounts and 500 in the last. So you can quickly eyeball and notice that there's twice as much in the AAA as there is in the B, and they do add up to 25,000. The other condition might be a little bit harder to check, but you can just plug that into the second equation and it should work out. But here's the beautiful thing. So let's move to part B, and I'll just write a space for it here. Part B, it says everything else is the same except we want 30,000 total and 1985 in interest. So you notice that if I look at my system of equations, the only numbers that are changing are those two. So we have the same A as we did before. So that means that X is equal to A inverse times a new B, newbie, get it? Okay, that was cheeky. 30,000, 1985, and 0. You get corny jokes for free too. So all I have to do is multiply the same A inverse times this new column matrix which is 30,1985 and 0. Well, it just so happens I have that in here. So if I go to matrix and I go to, I have that in C, there it is. So all I'm going to do is I'm going to pull up A inverse B, and I'm going to change the B to a C. And there's our solution to that. Okay, so it looks like our solution is 14,000, 9,000, whoops, 9,000, and 7,000. All right. Now, part C, there was yet another scenario. The values in part A are changed to 40,000 and 2660. So what we want is a total investment of 40 grand and an interest return of 2660. Well, it just so happens that under the matrix menu here, I have that matrix all ready to go. There's the right-hand side. So I'm going to take A inverse and multiply it by D. And there is that answer right there. So in C, all I have is 24,000, 4,000, 12,000. And there again, you can see that it meets the two conditions really easily. The interest one, again, it will work. It's just not apparent from the solution. So in summary, using matrix inverses is very useful if you have the same, what I'll call the background information. You know, we have a total investment of, we have a total interest yield of, and we're using the same interest rates, and we always want twice as much of one as the other. Those things are staying the same. So that means I can use the same inverse on different outputs, different goals, whatever you want to call it, and easily get my solution. So I hope this is helpful, and I hope you find great use for matrix inverses, and thanks so much for watching.